Now let's talk about Einstein. We all know of Einstein, and in class you'll get to hear this video clip of Einstein actually speaking. Einstein was very famous, of course, and he's, of course, all over my walls. He made some fundamental changes in the way we think about physics. Now, in 1905, he showed that mass is energy and energy is mass. This was a totally revolutionary concept. In his words, he said the mass of a body is a measure of its energy content. So, pretty much, so if you gain weight and you have a mass that has a larger mass, then it's not that it's getting bigger, it's just that it's getting more energy. Now, everyone knows the equation E equals mc squared. Basically what it's saying is energy and mass are equivalent and they're related by the speed of light squared. Now it applies to everything. Everything follows E equals mc squared. Remember, energy goes into heat when it gets absorbed. And so we have to take into account all of the energy that we're dealing with. In our ordinary life, we don't notice this, all right, because C is so very, very large. We don't detect the energy, the mass change. Let's look at what happens when you have 1 kilogram mass. All right, how much energy is in a 1 kilogram mass? Well, M is 1 kilogram. C squared is 3 times 10 to the 8th. You have to square this. So this is 9 times 10 to the 16 joules. Let's think about this. A 1 kilogram mass gives you enough energy to, it's the energy output of a large power plant for 1 year. So a 1 kilogram mass can power a large power plant for an entire year. Remember, the nucleus is made up of tightly bound particles. If some of these are weak, then it can break apart, and then you get energy out. You know where we're going with this. We call this a rest mass of the nucleus. And what happens when you break the nucleus up and you wind up with two daughter particles, you get out a good deal of energy, and this energy is your rest mass. Now, don't worry about the conversion, but let's just look at this. If you take uranium-235 and it decays, you get quite a bit of kinetic energy. Here are your two daughter particles. Let's think about this. Remember, a 1 kilogram mass will uh, be the could provide the energy output of a large power plant. 1 gram of mass is about what we released in the atomic bomb. 1 gram of mass is the energy equivalent for what we used in the atomic bombs. So, Einstein says mass and energy are equivalent, and this is completely different from Newton. They did not accept Einstein's postulate to start with. As a matter of fact, when he won his Nobel Prize, they would not let him speak on E equals mc squared because they didn't agree with it, and um, they thought he was full of it, actually. Now, we have a brand new paradigm. Paradigm's just a way of thinking. And that gave us special relativity, because if energy and mass are related, then as you use energy, mass changes, and it gets really, really cool what happens. So Einstein came up with another concept that nothing can go faster than the speed of light. And the faster you go, the more massive you become. And the faster you go, the shorter you get. It's kind of interesting. So as the speed increases, more energy goes into increasing the mass, less goes into increasing the velocity. Basically, he also said you can never reach the speed of light. You can get awful close, but you can never reach the speed of light. And you personally can't ever. So when we look at E equals mc squared, when the velocities are very small, Newton is dead on. It's completely correct. All right. And remember, E equals mc squared applies for all energy and all masses. However, it's just usually way too small for us to detect it. And remember, when you take a nucleus and you break it up, you can determine the rest mass of the of the atom based on the mass of the particles, the particle and the daughter particles.